Welcome to Learning Intention 1, Distance and Midpoint. Today we're going to be jumping into a new topic for graphing and simultaneous equations. Now this particular topic, it lands on the map of mathematics right near the center. So we're building tools around structures, spaces, geometry, all that sort of great stuff here. Now this particular topic, it's fundamental to a number of other topics that you'll be studying in years 11 and 12, so it's a good idea to study pretty hard in this one. Now to start off, let's look at a question, and we'll say we've got 2 points of interest on the map, one here, you might notice this as school, and one over here, the Westfields in Marion. And the question at hand is, what is the distance between our school and the shops? Now, to be able to do this particular chapter, we're going to rely on material from the previous grades, so year 9. But rather than just assuming that we know everything from the previous year, what we're going to do is we're going to go back a little bit. So distance, you might have done this last year, but we'll spend a bit of time doing it once more. So let me zoom up, and here we go. So to calculate the distance between 2 particular points, we've actually got a formula that we can rely on. It is d equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And you might think this formula looks a little bit familiar, and if you think that, you are right, because it is in fact just a rehash of Pythagoras' theorem. Now you might be asking, how does that relate? Well, if we look at our point here and our point here, we can draw it in the form of a triangle. So our direct distance is this orange section here, but this distance can be broken down into 2 components, the y component and the x component. The y component being the vertical component, and the x value being the horizontal component. Now we can't simply work out this distance straight up, but what we can do is take smaller calculations, so we can figure out the difference in the y's. So how far this is apart from this point in terms of y, and how far it is apart from this point in terms of x. Then we can plug it into Pythagoras' theorem and we can compute the distance, or we can simply just plug all the values into this formula here. But this one's a little bit bigger, so I actually prefer this one. But anyway, we'll use the distance formula up here and we'll calculate it. So over on this page, I've got our first point 5 and 3 and our second point 9 and 1, and I've drawn the triangle. Now our distance formula is d equals x2 minus x1 squared plus y2 minus y1 squared, and that is all square rooted. Now the choice we have to make is, which points do we want to have x2 and y2, and which points do we want to have x1 and y1. And the question is, it doesn't really matter which point is point 2 and which point is point 1, so long as we're consistent. So if we say that 9 is point x2, then we also have to say y2 is 1. So if this is point 2, we have to put it as x2 and y2 respectively, or if we say this is x2, then both this 5 and the 3 respectively have to go in as x2 and y2. But for this case, we'll say 9 is x2 and we'll say 5 is x1, so that will become 9 minus 5 all squared, then 1 minus 3, 1 minus 3 squared, taking the square root of all of that, evaluating. Now I could throw this all in the calculator at once, but if I do that, it's prone to making, or I'm going to be prone to making a mistake in inputting it, so it's better to work it out piece by piece. So this will be 4 squared plus 2 squared. Notice that 1 minus 3 is negative 2. So I should put a negative there, but it doesn't actually matter because it's squared, so the negative is going to get cancelled out. Evaluating that, I'm going to get 16 plus 4, and then I'll get a final value of 20, or the square root of 20. Now, I don't have my calculator on hand at this point in time, but what I can do is I can break that down even further, and I can say it is 2 times 2 times 10, which will be the same as writing, actually no, I've made a mistake. 2 times 2 times 5 is equal to 20, and that will become 2 root 5. But you could just leave it at here, or you could put root 20 into your calculator, and you could say that equals roughly, that would be roughly, I suppose, 4 point something. Now going down, what we've got is a few questions on finding the distance over here. So again, 5 and 7, 1 and 4, the distance is going to be, simply put it in the formula, 1 minus 5 all squared plus 4 minus 7 all squared, and then the square root of those. Doing it again, we're going to get negative 4 squared plus, that will be negative 3 squared. That will become 16 plus 9. So the square root of 25, I know that off the top of my head, 5 times 5 is 25, so the square root of 25 must be 5. Going across to B, distance is going to be 7 minus 7 all squared plus 8 minus 4 all squared. 7 minus 7 all squared, that will be 0, or 7 minus 7 is simply 0 squared plus 8 minus 4 squared, that is simply 4 squared. 0 cancels that, and it becomes root 16 is simply 4. This one's actually a pretty interesting one in that, imagine 7 and 4, 7 and 8. The two x's are the same, so what you've actually got is in fact a straight line that goes down like that. So that would be 7 and 8. This one would be 7 and 4. So the question at hand is, if it's a straight line, you can just look at it and say y2 minus y1 would simply be 8 minus 4 is a length of 4. So you could say, or you could look at it and say, oh, the x values are the same or the y values are the same, and just take the difference, and that would be our answer. Or you could plug it into this formula, and this would be the long route to get to the answer. Now going on to another example, we've got d equals square root of, we'll say negative 3 take away 5 all squared plus 5 take away 0 all squared. Computing this, we've got negative 3 take away 5. These are going to add together because they're both negative, so that's negative 8 squared plus 5 squared. Negative disappears because it's negative 8 times negative 8, so it becomes 64 plus 25. And that one becomes 89 by the looks of it. And you might ask yourself, what is the square root of 89? Well, 9 times 9 is 79. So 43. Oops. 9.43. And then finally over to D, the distance is 4 minus 6 all squared plus -7 minus 3 all squared. And 4 minus 6, that's -2 squared plus -7 minus -3, that's -10 all squared. The negatives disappear, so it becomes 4 plus 100. It's the same as writing the square root of 104. And bringing my calculator up one more time, we can say 104. And the square root of that is 10.198. So 10.198, and rounding to 2 decimal places, that's going to be 10.20 because the 8 rounds up, causing this 9 to round up, so 20. So those are some examples of how we can calculate the distance between 2 points. Now, the next point of interest we're moving on to today is calculating the midpoint. Well, what does that mean? Consider we've got our 2 points once again, and you're going for a walk, or you're at school and your friend is already at the shops and you want to meet up. And the question at hand is, you want to meet up at the midpoint or halfway, so meet 50-50. How can you do it? Well, we can use the midpoint formula. So midpoint equals x1 plus x2 all divided by 2 and y1 plus y2 all divided by 2. A good way to look at this is it's very similar to calculating the average. So you're taking the average of the x values and the y values. So you've got 2 coordinates, 2 x values, 2 y values. Simply add them together and then divide it by 2. So that will give you the point in around there. Moving downwards, so our midpoint is just over here. So how can we calculate the midpoint in this instance? Well, let's have a go. Similar to the last time, it doesn't actually matter what we decide is point 1 and what we decide is point 2, because we're simply adding them both together. We just have to make sure that we're adding the x values together and the y values. So we'll say 5 plus the 9 here, divided by 2, and then 3 plus 1 divided by 2. Going down, we're going to get 14 over 2, 4 over 2, and that will go into the ordered pair of 7, so x equals 7 and y equals 2. So having a look at this, the halfway point on this y-axis between 3 and 1 is 2, and the halfway point between 5 and 9 is also 7. So this midpoint here, let's get a thicker pen, this midpoint is going to be 7 and 2. So not too tricky and nothing new that you haven't seen before. I'm sure everyone's computed the average. It's just remembering the steps behind or what we're actually trying to do. So the midpoint, we're trying to find the average between 2 particular points. Now let's look at a more abstract version of doing a few questions. So we'll compute the midpoint between these points here. Before we did the distance, now we're doing the midpoint. So 5, 7, and 1, 4 was the midpoint. Well, we can say it is, we'll go MP for midpoint equals 5 plus 1 over 2, and then 7 plus 4 over 2, this will be 6 over 2, and this one will be 11 over 2. So we're going to get a decimal in this case. 6 over 2 is 3, and 11 over 2, well, 10 over 2 is 5, and 12 over 2 is 6, so I know 11 over 2 is going to be 5.5. So this would be our answer for the midpoint. In this example here, 7, 4, and 7, 8. Again, remember going back to, let's zoom up, back to here, it was a straight line. So have a think, do you need to use this formula here, or could you just figure it out? And if you're really smart, you'd know that the answer for the midpoint, actually I'll move it downwards. Simply looking at it, you know the answer is going to be 7 and 6, or if you really want to work it out, you can say that it is 7 plus 7, and then 4 plus 8 over 2. 7 plus 7 is 14, divided by 2 is simply 7. And then 4 plus 8 is 12 divided by 2. 12 divided by 2 is 6. So our midpoint in this case is 7 and 6, as we conjectured up here. Now in C, we'll put in the formula again. Notice that we've got a negative in this case, but irrespective, let's continue on. We'll say negative 3 plus 5 over 2, and then 5 plus 0 over 2. This will give us a midpoint of negative 3 plus 5, that is positive 2. 5 plus 0 is 5 over 2. We're going to get a yucky decimal again, but irrespective, 2 over 2 is 1, and then 5 over 2, that is 2.5. So our midpoint in this example is 1 and 2.5. Then finally in D, our midpoint is 4 plus 6 all over 2. Then negative 7 plus 3 all over 2. Computing these values, 10 over 2. And negative 7 plus 3 over 2, that will be negative 4 over 2. And thus we have 5 and negative 2. So the midpoint in this example is 5 and negative 2. So looking back in summary, what we've done is we started off looking at the distance and midpoint. First we jumped into the distance and we asked ourselves, what's the distance between high school and the shops? Well, we used our formula here, which is a rehashed version of Pythagoras' theorem. So you can simply draw a triangle to work this out if you forgot this formula. And then we plugged it in and we found the distance was 2 root 5, which was roughly 4 point something. So this would be our distance here that we worked out. And then in the second part, we looked at finding midpoint. So say, for example, if you're at Brighton High School and your friend was at the shops and you want to meet halfway, well, you'd simply put the coordinates into the midpoint formula and you'd be able to work out the point at which you need to meet at to walk halfway each. So your midpoint here, in this case, it was 7 and 2.